Welcome to Get Your FRQ On. This is from 2008, Form B, Question 3, and it is calculator active. In the question stem, we've got scientists measuring the depth of a river, which is 24 feet wide. The measurements are taken in a straight line perpendicular to the edge of the river. There's data in a table which shows the distance from the river's edge that the measurement is taken and the actual measurement of the depth of the water at those points. The velocity of water here is modeled by a function v of t, and that function is good for 0 to 20 minutes. In part A of this question, we are asked to use a trapezoidal sum using 4 subintervals indicated by that table to approximate the area of a cross-section of the river. So the area of a cross-section of this river can be found by calculating the trapezoidal sum using the 4 subintervals provided by the table. This is the expression 8 times 0 plus 7 over 2 plus 6 times 7 plus 8 over 2 plus 8 times 8 plus 2 over 2 plus 2 times 2 plus 0 over 2. So when we calculate all of this, let's see, 8 times 7 over 2 plus 3 times 15 plus 4 times 10 plus 2, add all that stuff up, and you get 28 plus 45 plus 40 plus 2, which turns out to be 115 square feet. Make sure the label is correct here. We are calculating an area, so make sure that your unit is a unit of area. In part B of this question, we are asked to estimate the average value of the volumetric flow at Picnic Point in cubic feet per minute from t equals 0 to t equals 120 minutes. By definition, the volumetric flow is the product of the cross-sectional area times the velocity of the water at that location. The average value of that volumetric flow from t equals 0 to t equals 120 would then be found using the formula for average value of a function. We get 1 over 120 times the integral from 0 to 120 of 115 times v of t dt. Since this is a calculator active question, we will use a calculator to evaluate that integral. 1 over 120 times the integral from 0 to 120 of 115 times v of t dt turns out to be 1,807.170 cubic feet per minute. And remember, since we're talking about volumetric flow, our label should be a unit for volume. In part C of this question, it is suggested that the function f of x equals 8 times the sine of pi x over 24 can be used to model the depth of the river x feet from the edge. And then we are asked to determine the cross-sectional area from this model. So using the given model, the desired area is the value of the definite integral from 0 to 24 of f of x dx, which is the integral from 0 to 4 of 8 times the sine of pi x over 24 dx. And since this is a calculator active question, we will use our calculator again. The integral from 0 to 24 of f of x dx is the integral from 0 to 24 of 8 times the sine of pi x over 24 dx. And that turns out to be 122.231 square feet. In part D of this question, we are asked to find the average value of the volumetric flow during the time period from 40 to 60 minutes. And then we are asked if water must be diverted. And in order to really understand this question, you're going to want to refer back to the original statement of this question. That link is provided in the description because this question gets kind of wordy. Make sure you have that open. So what we need to determine is whether the average value of the volumetric flow between t equals 40 and t equals 60 minutes is greater than or equal to 2,100 cubic feet per minute over that interval. That average value can be found by using the average value formula, 1 over 20 times the integral from 40 to 60 of 122.231 times v of t dt. And if that is greater than or equal to 2,100, water would have to be diverted. Since this is a calculator active question, we're going to use our calculator to evaluate the integral. 1/20th of the integral from 40 to 60 of 122.231 times v of t dt turns out to be 2,181.913 cubic feet per minute. And since the calculated value 2,181.913 is greater than 2,100, yes, water must be diverted. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.